Good morning, everyone. Can you all hear me?
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning.
Good morning, sir.
Okay, good morning. I'm having a bit of net. Good morning. I'm having a bit of network
Good
issues,
morning,
so
sir.
there could be a scenario where we might just get locked out. I might get locked out. So, you know. Good morning. All right. So let's predict, and these are some of the drawbacks of online classes. Okay. So let's begin. I think there are already more than 40 people in the class, and if you look at the screen which I'm sharing, this was yeah. I just got disconnected again. Are you guys able to hear me?
Yes, sir.
Yes, sir.
Okay, fine,
Yes, sir.
fine. So in the last class, I had told you how to convert a binary number into a decimal number and how to convert. Shubham, can you please mute your microphone? Shubham,
Hey,
Shubham, please mute your microphone. Okay, right. So I was telling you how to convert a binary number into a decimal number and how to convert a decimal back to binary. That was what we had done in the previous class. Now, the reason why we had done the same was that we are going to learn, a kind of operators in C, which is called as bit manipulation operators. So when we discuss the bit manipulation operators, we will have to, convert everything into binary, because all the operations which are done by the bit manipulation operators are on the binary number. For example, if I take an operator that is addition, right? If I have an operator called as addition, then we know that it works on two integers. Like if I do 5 plus 4, we get 9. And the operation is being performed on an integer. But when we use the bitwise operator or the bit manipulation operators, the operation does not happen on an integer. But what happens is this integer is converted to a binary number, and all the operations which we define using those various operators, they will be done on the binary bits. Okay, so that is the reason it's important to understand or to know what is, how the binary number and decimal numbers are represented. So how you can convert a binary into decimal and decimal into binary. All right, so let's start with some conditional operators. Let's start with some more operators in today's class. So I hope all of you are comfortable with conversion of binary into decimal and decimal into binary. All right, so earlier you have learned some important operators in C. So you have learned operators such as the arithmetic assignment operator, you have learned the increment and decrement operators, right? And you have also learned the relational operators. Now today we are going to learn a very important operator, it does not have a symbol, but it is represented with a word which is size of. Okay, so we are going to learn about this operator today. Then we are going to learn about logical operator. Okay, we are going to learn about logical operator. Very important. Okay, this is also very important. After that, we will touch the bit manipulation operator. Okay, we will touch the bit manipulation operator. And finally, we will look at a unique operator, which is called as the conditional. Okay, it is called as the conditional operator. What is the unique thing about this conditional operator? The unique attribute of this conditional operator is that this is the only operator. Okay, this is the only operator which works with three operands. Okay, I think all of you know what are operands, right? So this is the only operator which works with three operands. Most of them work with two and one. We know that this works with only one. There is only one operand here. Okay, this is an operator and this is the operand. So this works with only one. If you have A plus B, we know that there are two operands. But this is the only operator which has got three operands. So that's why it's unique. Okay, and it's special. So when we come to the conditional operator, we will learn that. But this is a very, very popular question for your placements or for your interviews. You know, when you go and attend the interview, they will ask you, can you tell me in C which is the operator which has got three operands, which uses three operands? So you know exactly that we are talking about the conditional operator. So this is a very popular question for your placements or your interviews. All right. Now, let's first look into the size of operator. Okay. Now, when we talk about size of operator, we basically, it gives us a very clear picture that we are trying to find out the size of something, right? We are trying to find out the size of something because this operator itself has the name size of. Okay. Now, what you can do with this operator is you can measure the data type size. You can measure the data type size. Excuse me. When I say data type size, what do we mean by data type size? Now, data type size means what is the size of the container? Because I had told you in the previous class that the size of various data types is not fixed. For example, size of integer, it can be 4 bytes, it can be 8 bytes. Size of a float, right? A floating point number can be 4 bytes, can be 8 bytes. Now, this is dependent on your compiler. Okay, this is dependent on your compiler. So if you are using a particular compiler, it might have the integer 4 and the floating 8. If you are using some other compiler, it could happen that integer they are giving only 2 bytes of storage, and floating they are giving 4 bytes of storage. So every compiler has a variation in the container size. That means some can define the size as 2 bits, some can define the size of the floating point as 4 bits, some can define the double as 8 bits. So these values are not constant. That means the size of integer, size of floating point numbers, or a double or a character, they are not a constant value because it changes with the kind of compiler you have, also what type of machine you use, right? So using this operator, which is size of operator, you can identify, you can find out what is the size of your data type. All right. Now, how do you find out? Very simple. Okay. The general form for the size of operator is you have to write size of and you have to give some expression. Now, this expression and then you put a semicolon. So this is basically how you find the size of operator. Now, let me give you an example. So I can write something as size of, I can straight away write int. Okay. Now what this will give is this will place the size of integer that that particular compiler or that machine basically allocates in bytes. Okay, in bytes, 2 bytes, 4 bytes, 6 bytes. Okay, and it will place it, that value, it will place it in a variable. Now that variable can be anything. I can say, like, let's say the name of the variable itself is size. So what it will do is this operator will return the size of an integer. So it can be 2, it can be 4, it can be 6, it can be 8, whatever size the compiler is basically allocating for an integer, and that value will be returned into this variable. Now what you can do is I can straight away print this. So if I print this variable, if I print the data which is inside this variable, I will know exactly what is the size of an integer. Now similarly, this integer can be replaced So you can have, in place of integer, you can write char, or you can write float, or you can write double, right? So any data type you want to know the size of, you can use the size of operator. Okay. So now the size of operator can also be used in a different context. That means if suppose you don't want to use these data types, but you have the real number. That means you have the real number. Suppose I have 30. Okay. Now I want to find out this, what is the size of 30, whether if I have declared this number as, say, integer, right, I can still find the what you call the size of this integer. So let's see how we can do that. So there is a small change. There is a small of change in the format of how you use it. Okay. So if I have, say, let's say I'm declaring an integer, and this integer is, say, int underscore num, and I'm initializing it to 0. Okay, that's simple. Now if I want to print, there are two ways by which I can find the size of this int. One is I can straight away print size of, and then I can write int. So this will give me what is the size of the integer, right? And you can print it in, like, okay, if I let me just write this entire line so that it's clear for you. So I can write a statement like printf, okay, and then I can write, say, for example, the size of int is equal to, right? I can write percentage d. So I want the size in the decimal format. Okay, I can say, right, byte. All right, because this size of returns everything in bytes. And now I can write size of, and I can write int here. Okay, so this is my program. So if I write this line, what's going to happen is percentage d is basically a placeholder where I need to input some value. This value is going to be returned by the size of operator. The size of operator will return the size of what that integer holds, and that value will get printed here. So if your compiler has allocated a size of 4 bytes to an integer, the statement will get printed as 4 bytes. All right. Now, suppose I don't want to use, int, and I want to use some number, or I want to use some variable. Like, for example, I have a variable. I can also find the size of the variable. Okay. So the same line, I can also change it as, like, for example, let me just make a small change here. Okay. So this is all fine. So what I do here is I just, in place of this, I'm going to write size of. Now I don't want to write int, but I want to give the name of the variable. So what is the name of my variable? The name of my variable is int underscore num. Okay, and then you can close it. This will also return the size of this variable, which is actually basically an integer. Okay, so you can use the size of in two ways. One is if you're directly using the data type name, then you have to include the bracket. If you're not using the data type name and you're using the variable name, then you have to write it this way. And remember that there has to be a blank space here. So you write the size of, that is the name of the operator, and then you use a blank space, and then you write the variable name, and it will give you the output of that particular integer. So basically, it's not going to give you the output of the amount that this integer is holding in that memory space. So for example, if this is your integer and your variable is occupying only this space, it is not going to give you this size. It is going to give you the size of this entire container. Okay, so the size of operator is a very useful operator to find out the size that the compiler and the machine is allocating for your different data types. Did you understand this? Did you understand,
Yes,
all of
sir.
you? Okay, very good.
Yes, sir.
Excellent. So next we will we will touch upon another operator that is very, very useful, and it's going to be used very rampantly in your program, and that is called as logical operator. Okay, it's called as logical operator. You must have already used it probably, right? But these are very powerful operators. Okay, now in C programming language, and these logical operators exist in all programming languages. Okay, so don't think that you're only learning C here, because this is a generic. The C programming language is a generic programming language with many of the concepts, many of the operators, many of the fundamentals are used across all the programming languages. So even in other languages also, you need to have logical operators. So in C, because we are going to write programs in C this semester, there are three logical operators in the C programming language, and they are represented using these symbols. Ampersand, and then you have this one, okay, and you will find this symbol somewhere in your keyboard. Well, I don't have the keyboard with me right now, but it's there, probably above the enter or somewhere you'll find this symbol. Okay, and then the third one is an exclamation mark. Okay, so these are the symbols for three different logical operators. Just like how you have symbols for addition and subtraction, right? You have symbols for these logical operators. All right. Now the first one, is called as the logical AND operator. Okay. The second one is called as the logical OR operator. So if you are studying digital electronics, or if you're studying computer architecture, these are the few things that you must already be learning. You must have already learned this AND operator and what exactly AND is, what exactly OR is, right? Operator. And the third one is called as negation operator. Okay, negation operator. Okay. All right. Now, these two operators, right? The first two, the and the or operators, they are binary operators. Okay. The binary operators means what? Binary operators means it has two operands. Binary operators, they are binary operators. What is the meaning of two binary operators? It means that they work on two operands. Okay, they will work on two operands. So plus, right, this is binary because this has got two operands. Minus can work in two ways. Minus is a binary operator, and it is also a unary operator. What is the meaning of unary operator? Unary operator means it has got only one operand. Binary means two operand. So this minus has got, it can either be used as a binary operator or it can also be used as a unary operator. So basically I can write a statement A is equal to B minus C. So if I'm writing this minus is being used as a binary operator because it is working on two operands, right? But I can also write a statement as A is equal to minus B. That means if the value of B is 5, it will change into minus 5. Now in this case, this minus is working with only one operator. So this minus in this case is a unary operator. Okay. So you know what is the difference between a unary and a binary operator. So in this case, when we're talking about the logical operators, these two, the AND operator and the OR operator, are binary operators, whereas the negation operator is a unary operator. That means it will work with only one operand. Okay, now what exactly is the use of these operators? Now, these operators are used mainly when we are handling conditions. Okay, when we are handling conditions. So, for example, like when we talked about the for loop, right? So, for say I is equal to 0 and j is equal to 1, we had written something like that, and we said I is less than 5, right? Suppose this is our for loop, and you're incrementing I, and you are also say incrementing j. Suppose we have a for loop here. Now, in the previous examples and the previous programs that we've done, we have used only one condition, right? This is the condition. What is the condition? I is less than 5. But what if I want to add some more conditions? Suppose I want to add two conditions or I want to add three conditions. So when I add conditions, the conditions are normally, added, like for example, you go to the market and bring this, right? Or you go and go outside if it is raining, or there is water, whatever it is, or if the car is unlocked, then do this. So basically, when we talk about composite conditions, that means when we talk about multiple conditions, in order to evaluate multiple conditions, or when we talk about adding more than one conditions, we use these conditional operators. So I can write a statement like I less than 5, and okay, and we can say j less than 3. Now if you look at this, this was a simple condition, I is less than 5, but here I am adding two conditions. One is I less than 5 and j less than 3. Now this is a conditional operator here which I've used. So a condition operator, is very important because you can actually start working with multiple conditions. Or in place of this, I can also write, or means either of these conditions should be valid. Okay, that means this loop is going to get executed if any one of the condition is valid. That means if I is less than 5 but j is not less than 3, still this loop will run because one of the condition is valid. But when I change it into and, that means both the conditions should be validated. So if one is valid and the other one is not valid, this loop will not run. Okay, so these conditional operators are very powerful because they will help you make decisions in whether the looping should happen or not. So let's take a small example so that we can understand. Okay, let's take a small example. So let me write a small program. So I hope all of you can see and hear me clearly. So let's write a simple program and then we will understand how to use this. I think I should be using a black pen because the red is too bright. All right, so let's write a simple program, and all of you are comfortable with what I'm doing here, right? So I'm not writing anything here. I'm just writing this main because we know what happens in the main. And let me declare an integer. So all of you know what I'm doing. In this line, I am just declaring an integer. And in the second line, what I'm doing is I'm initializing a value 0 to this integer. Now here I'm going to use this operator. This operator, what it does is, so if I have a number 5 and I use this operator and I give, so basically, can anyone tell me what this operator is going to do?
So it will give the reminder.
Absolutely. So when I do 5 divided, sorry, if I use the division operator, which is equal to 4 divided, sorry, making a mistake, 4 divided by 2, the answer will be 2. But in this case, it will give the remainder. Okay,
Press the one.
remainder. So just remember that there is a small difference in this operator. 6 divided by 2, the answer is 3. But 6 equal to 2, answer will be 0 because there is no remainder. But if I write 4, the answer will be 2. So I hope you know what this operator is doing. All right. So let's not get into the details, okay, of this because it's quite simple. Now, what we will do is we will try to write this program and see how this works. So let me just continue with the program. Okay, now let's write a print statement. So I'm going to write a print statement here. The and okay operator. Oops, sorry. I think everybody is kind of clear with what I'm doing here. Now I need to give a value here because I have given a placeholder. That means I've given a format specifier here. That means I need to give some kind of value there. So this part of my printf, I should have something which returns a value, right? That value can be anything. So since there is less space here, I'm continuing it below. Okay. So look at this now. Now I'm going to write this conditional operator. Now num is 0 here. So what I'm going to do is I'm going to do num percentage 2. Okay. And this basically will check this. All right. And I am also putting another condition here. Now see, there are two conditions which it is going to check. Num percentage 3 and equal to 0. Okay. And I close this line. Now let's look at this printf statement. What is going to be returned in this part of the expression? Can anyone tell me? Now this num is basically 0 here. So 0 percentage 2 is what? So what will be the output of this expression here? Who's going to tell me? Only this much, only this expression.
2.
No one? 2. So this is number is 0. 0 divided by 2. What is 0 divided by 2? What is going to be the remainder here?
2.
Remainder is 2.
2, sir.
Hmm? This is going to see. This is what is this going to return? Tell me. Don't get confused. What is this part going to return? This is going to return 0. Are you clear?
Yes, sir.
Yes,
0.
sir.
Everybody is clear about this part? This part is going to return 0. Now we are checking. We are checking whether the 0 is equal to 0 or not. So is this true or false?
True.
0 is true. So if this is true, then this entire expression will be returning what value? 1.
1.
Are you all able to understand this?
Yes, sir.
Okay. If this value is going to return 0. Now we are using an operator to check whether this 0 is equal to 0 or not. Yes, 0 is equal to 0. So if 0 is equal to 0, what is it? It's true. It satisfies. So if it is true, then it is going to return 1. So this part of the expression is going to return 1. Are you all able to understand? All right.
Yes, sir.
And now this and comes here. And now let's look at this part of the expression. So num percentage 3, which is 0 percentage 3. What is this going to return? This is going to return 0. Right? So this is going to return 0. And 0 is equal to 0. So yes, it is true. So if it is true, it is going to return 1. Right? So this is going to return 1 and this is going to return 1. So I have 1 and 1, which means this is true and this is true, which means only if both the conditions are true, then this entire statement is true. So in case of AND operator, you have a logic. The logic is if you use the AND operator and one side you have an operand, one side you have an operand here. So if this returns true and this returns true, the answer will return true. If this returns false and this returns false, this will return false. If this returns true and this returns false, it is still false because I want both the conditions to be true, right? Are you getting the point? Only and means this and this. Okay, I will eat a chocolate and an ice cream. What I'm saying is that I want both. You have to give me a chocolate as well as you have to give me an ice cream. But if I say I will eat a chocolate or an ice cream, it means that I can have a chocolate or an ice cream. Any one is fine. But when I'm using and, it has to be chocolate plus ice cream. That means if both are there, then only I will have, right? So if both are there, then I will eat. If if nothing is there, then obviously I will not eat. But if chocolate is available and the ice cream is not there, I will not eat. If the chocolate is not there and the ice cream is there, I will still not eat, because when I say and, I mean that I should have both of them. So in this case, I have true on the left hand side and true on the left side. That means this entire thing, I will get a value 1. So what will get printed in this entire expression is 1. So what will be the output here? The output here will be the AND operator gives 1. Did you understand?
Yes, sir.
Okay. Now if I change this to OR, if I change this to OR, and we know that the OR is represented like this, okay? So in this case, I will have an ice cream, or I will have chocolates, okay? So if ice cream or chocolates, and if both are there, good for me, 1. If there is no ice cream, there is no chocolate, obviously it will be 0. If there is ice cream and no chocolate, still I will have, because I said I can have an ice cream or a chocolate. Here in case no chocolate, but I have an ice cream, so yes, I will also have 1 here. That means in case of OR, right, only if both the operands are false, that means 0, then only you have the answer as 0. In all the other scenario, you will have 1, 1, 1. Okay, so in the same example, if I change this AND to an OR operator, what will be the answer here? The answer will still be 1, because this is going to give 1, that is ice cream, and here is my chocolate, and ice cream or chocolate. So yes, I'm going to have. Okay, my decision is true. My decision is it's a logical true. Okay, now let me change this a little bit, and I'm going to, change this printf statement. And let's say I am going to change the value of 0, and I will make this value as, say, 2. Now, can you tell me what is going to happen here? Now, when I change the value of num to 2, this side it's 2 percentage 2. So what is the result of this? 0. So 0 equal to 0 means I'll get 1, right?
But
And then this is and here this num is 2 and percentage 3. Now here I'm not going to get 0, right? I'm not going to get 0. So this part, so if this is not 0, then this equal to 0, that means whatever number is here is not equal to 0. So eventually this entire thing, I will get, say, 0, because it is not equal to 0. So here it is true and here it is false. That means the entire thing will evaluate to 0. Okay, so what will get printed is the AND operator gives 0. So when I have the number 2, what the value comes out is 0. The third one, so if I change this number to 3, then this part will become 0 and this will become 1. So this will become 0. But if I change this to OR, okay, if I change this to OR, then what's going to happen? This is 0, this is 1, but the output, if it is an OR, if it is OR here, then this is going to change into 1. So did you understand what's been happening in this program, and what is a logical AND and an OR operator?
Yes, sir.
yes, sir.
Okay, fine, good, good, good. Okay, and there is one operator which is basically called as logical negation, right? This is logical negation is given by this exclamation mark. All right. So what happens in this case? It will reverse the result. It will reverse the result. So suppose I put here, look at this. I have put a logical negation. So what this will do is, suppose the number is 2. So 2 percentage 2 will give what? It will give 0. Now 0 is equal to 0, yes. What this will result? This will result into true. But I have used a negation operator. So whatever is the result, it will reverse it. That means the output of this will become 0. So if I use a negation, whatever the value is, evaluated here, it will give the negation or the opposite value for this. So if this translates to 0, this negation operator will convert it into 1. If it translates to 1, this negation operator will convert it into 0. Okay, so this is very simple, and I think we need to do some programs here. So but it's kind of simple because you'll be, when you're using the loops, when you'll be using the loops, for loops, you'll be using a lot of these these operators, logical operators. Okay, so our this is quite simple. You will be doing this in a lot of programs, so we can skip this for now. But what we are interested in doing is using the bit manipulation operators, and they are, when somebody asks you a question, okay, on operators in C, if you go to any interview and if they ask you questions on operators in C, bitwise operator is what they are going to ask you, because all the others are very common and they are very simple, but they will ask you about bitwise operators. Okay, now this is also called as bit manipulation operators. Okay, now in order to understand this bitwise operators, right, let's first list down all the different operators. Now, you know what were this, right? You know this. This was what? Logical and logical or. Okay. Now, if you use two ampersands together, you call it a logical and. If you use these two symbols, you call it logical or. Okay, but bitwise operators has got only one ampersand, right? And it has got this one straight line here. Then it has got this operator. These are all symbols of your bitwise operators. I'm just listing them down. I'll tell you one by one what they do. Okay, right? So are you all able to see the screen?
Yes, sir.
Right?
Yes,
And
sir.
so these are the bitwise operators. Now be careful, because when you put two times, when you write these ampersand twice, it becomes, logical and operator. But if you use it once, then it becomes bitwise operator. Many times people, when they are writing the program, they make a mistake. See, this has two meanings. This has got another meaning. This has got another meaning. This is the arithmetic assignment operator, right? But here we are going to check now the output of this. It is going to check whether this and this are equal or not. Okay, we will check for equivalence here. But here, this is used in another context. This is used to transfer the values which is on the right hand side into the left hand side container. Assignment operator. Okay, so this is a logical operator. This is an assignment operator. So basically, you have to be very careful when you are using the operators, because if you use twice, it becomes logical and. If you use once, it becomes bitwise operator. Okay, so let me tell you a little bit about these bitwise operator. The first one is called as a bitwise AND operator. Okay, this is also AND, but it is called as bitwise AND. Okay, it's a different. This is bitwise AND. Okay, now what this operator does, it does not work on integers. What it works on is your binary digits. Okay, that's why I had taught you the conversions. Now let's try out this example. Let me say I take an integer where a is equal to, let's give it a value, let's say 60, and let's give another value to b. B is, say, 13. Okay, now say I have declared two integers. In one of the integers I have put the value 60, another integer I have calculated the value 13. Right, now if I perform an operation a and b, right, if I perform the operations a and b, what will be the answer here? Now, in order to find the answer, what we have to do is, first we have to convert this 60 into binary. Can anyone do it and let me know what is the binary equivalent of 60? I had done it that day, so can anyone quickly, one person can do the binary equivalent of 60, one person can do the binary equivalent of 13 and give me the results quickly within 1 minute. I'm waiting, okay? Let's see who can give me the right answer. What is, change this 60 into binary, change this 13 into binary and give me the answer. Anyone is doing it? Please let me know if you're doing it, otherwise I will do it. Okay, while you're doing it, if others are not doing it, please, yeah, anybody has got the, what was the A? Tell me what.
11110.
Okay.
4100.
Okay, 111100. Okay, anyone for B?
Yes, sir.
And while
Double
you're
one
doing it,
zero
if you
one.
double
Double
one,
101.
1101.
double one.
01.
Okay, very good, very good. Thank you very much. So, meanwhile, please can you give your attendance? Just write your roll number, write your full roll number in the chat box. All right, write your full roll number in the chat box. Okay, so we've got the binary number for A and we've got the binary number for B, right? So when we actually look at these operations now, that when I do A and B, that means I'm using A and bitwise B, I have to do the operations on the binary number. So what I'm going to do is, let me write this 111100. That was for A, right? So in order to, make it, let's make it into, we'll add two zeros here, so we'll make it into a 8 bit number. Okay, and then you have 1101, so I write 1101 and I will also write 4 zeros here to make it into 8 bit, right? Everybody is okay with this? Now I want to perform an AND operation. So you know what happens in AND operation, right? Both the operands have to be AND in order to get 1. So what happens in bitwise operator is, when you're going to perform an AND operator, first you converted it into binary and now you check for each bit. Why it is called as a bitwise operator is because it checks for one bit, you know, bitwise. Okay, so one bit at a time it will check and do the operation. So 0 and 1 AND operation is what? 0 and 1 and
0,
absolutely 0 and 0, 0, 1 and 1, 1, 1
1.
and 1, 1, and then you have all the 4 zeros. So this is my result, but what I will get on the screen is not this, because this will be converted back to decimal. Now who is going to convert 1101 into decimal and tell me?
Sir, 12.
12, sir.
12. Okay,
Yes, sir.
fine. So 12. This is my answer which I get. So if I have two integers, 60 and 13, right, and I use a bitwise operator, that is bitwise AND, so my answer is going to be displayed as 12. So now, if somebody says 60 and 13 is equal to 12, how? You know what is the internal logic? Everybody knows what's the internal logic,
Yes, sir.
right? Okay, now suppose in place of this AND, I'm going to do bitwise OR. So same thing in bitwise OR, let me write this number, and this was 1101, and I'll write the 4 zeros here. Have I written the 4 zeros? I missed, I think I've written only 3. So 0000111, right? Yeah, it's right. And now I'm going to do the OR operator, OR operation, right? So this will become 1, this will become 0, this will become 1, this will become 1, this will become 1, this will become 1, and this will be 0. Everybody got this?
Yes, sir.
Yeah?
Yes, sir.
Okay, fine, fine. So, uh, so this becomes 111101.
61, sir.
Okay, absolutely. So 61. I was just waiting for someone to calculate this. So this becomes 61. So what will be the answer? The answer will be 61. Okay. So A 60 and B 13, and or you get 61. Right. Now you know exactly how you're getting this answer because internally how things are working. Right. Let's see now. These are. Let's take this one. Okay. This is basically called as one's complement operator. Okay, it's a complement operator. So this will work with only one operand. So if I do this, okay, it means that you are doing the negation. That means the negation of, this all the bits. So for 60, what we had calculated, 111100, right? And this was a number in 8 digit. So negation of this means what? The zeros will become 1 and ones will become 0. Are you all getting it? Okay. So
Yes, sir. Yes, sir.
So this is, you can calculate this later, what is going to be the decimal equivalent. So, a complement, A's complement will give you this. You can convert it into a decimal and that will be the answer. So this is simple, this is simple, this is also simple. Now this is called as exclusive OR. Okay, this is called as, exclusive OR operator. What is the meaning of exclusive OR? So let's say A and B are there and we use the OR operator. So this is the result. Okay, so in case of OR, when you have 0, 0, the result is 1. When you have 0, 1, the result is 1. When you have 1, 0, the result is, sorry, this is 0. And when you have 1, 1, the result is 1. Okay, now, is this correct? Everybody understood this?
Yes, sir.
Yes, sir.
Okay, right. Now, exclusive OR is a condition where the AND is not applicable. It is a condition where the AND will not be applicable. So, in case of exclusive OR, these are the two conditions which have only the OR. That means either one has to be 0. Okay, only if one is 0 and the other one is not, then you get 1. So, if I use exclusive OR, this will be 0. This is satisfied because one of them has to be 0. This also is satisfied because one has to be 0. But this is not satisfied because this is AND. This is not exclusive OR. This is an exclusive OR condition. That means either one is 0, the other one is not. But this is not an exclusive OR because this is true even for AND. So in this case also, if you are using XOR, that is exclusive OR operator, then this will also become 0. Did you understand?
Sir, can you repeat once more?
Okay. In exclusive OR operator, or this one, it will check for only the OR where, you should not have both the bits as true. Because both the bits as true is applicable for AND also and for OR also. That means it is not exclusive to OR. It is not exclusive to OR. We are going to look for only those conditions which are exclusive for OR. This will be OR and AND for both the conditions. When we talk about exclusive OR, we look at only those conditions which they are unique in terms of OR. That means one of the value should be 0. So if one of the value is 0 and the other one is 1, then we can say that this is exclusive OR. So this will be false and this will also be false. If I change this exclusive OR to only OR, then this is also true. But if I change it to exclusive OR, that means only those which are exclusive. This is not exclusive OR because this has also got AND. Okay, so only these two statements will be 1, all the other will be 0. Did you understand? So
Yes, sir.
if I perform an operation as A exclusive or B, so we know what is my A in terms of binary. we know what is my B in terms of binary. So my exclusive OR will be this satisfies because one of them is 0. So we're going to have 1 here. This is going to be 0. This, what is it going to happen? This is not exclusive OR because this is AND. It satisfies for and it satisfies for
0.
OR. So this is not exclusive OR. So we'll have 0. This will also have 0. This will have 1. This will have 1 and 0 and 0. Okay, so this is basically going to be your output, which will have to be converted into a decimal form, into a decimal number. So I think the decimal equivalent of this is 49. So this is going to be your answer. Everybody is okay with this one?
Yes, sir.
Yes, sir.
Do you have another? Do you have another class after this?
No, sir.
No, sir.
So can I extend for another 5 or 10
No,
minutes?
sir.
Yes, sir. You
Yes,
can
sir.
Yes or
extend.
no?
Definitely.
Okay. Okay. So I'll just extend because I'll finish off these two so that we can close this. Otherwise, since we are discussing binary and all that, we will try to close these two. Now, these are two interesting operators. Okay, so everybody is clear about the bitwise and the bitwise or, the bitwise exclusive or, and the complement operator or one's complement operator, right? So we have these two left. Now let's discuss these two. Okay, so let me just remove these stuff. Okay, now this one is called as a binary shift operator, left shift operator. Okay, and this is called as binary right shift operator. Okay, now an important point that these are unary. That means they will work with one operand actually. All right, so let's see how it works. So suppose I have A. Okay, suppose I have A and I'm saying that I am using this one, binary left shift operator, and I'm giving a value 2. What we have to do here is the binary, whatever is the binary digits, okay, these binary digits will be shifted by 2 places. Will be shifted by 2 places. Let's see an example. So for A, what was our binary equivalent? This was a binary equivalent. Everybody is okay with this, right? This was a binary equivalent. Now, when I'm using a binary left shift operator, that means this is going to shift towards the left by 2 places. So this was a number. So let's shift this entire number by 2 places to the left. That means this 0 will go out, this 0 will go out, these 1 will come to these places, this 1 will come here, this 1 will come here, then these two zeros and these zeros will get added here. There will be 2 zeros which will be filling up the places. So that means this entire thing has shifted 2 places to the left. Did you understand?
Yes, sir.
Now, what is the equivalent number of this? Can anyone tell me? Can you find out
60.
the decimal for this? No, it will be more than 60, I think. Check this. 11110000.
240, sir.
240. Okay, so the
Yes,
output
sir.
of this will be 240. This is going to be your answer. All right. Now, if I change this and make it to right shift operator, so what I do is I will change this symbol and I will make it into a right shift operator. So, what is a binary for, uh, you know, sorry, 111100. So, this is our binary for number 60. Now, this time I'm going to shift it towards the right. Okay, so when I shift it towards the right, by how many places? 2 places. So if I shift it by 2 places, that means I am going to get something like this one. So this is, what is the decimal equivalent of this? 15. Did you understand this?
Yes, sir.
So
Yes,
these
sir.
two are very important. The binary left shift operator and the binary right shift operators are very important. You will be using this. Why am I teaching you this? Because these are very important in the aspect, because when you learn networking, when you learn how the data is shifting, how the data travels through, one place to another place through different network layers, then these become very important. Okay, so when you are transferring your data, when you are downloading some stuff, they are going to compare, they check bit by bit, they check whether your data is completely downloaded or not. So there are a lot of applications where your bitwise operators are going to be used. There are a lot of applications in terms of operating systems, in terms of when you are writing programs for networking, when you're trying to build some network protocols. That's the place where you will be using these bitwise operators. So it's very important that if you know C programming language, you must know what are the bitwise operators. So in order to learn bitwise operators, it is important to first understand and know how to convert a binary number into a decimal format and a decimal number into a binary format. Because without understanding that concept, the bitwise operators, you will not be able to figure out what is happening. All right. So I hope everybody's understood this. If you have not understood this, I will, please go through this. Please go through this video once again. I will try and upload it on YouTube. I'm recording these videos because many of the students are coming in late, so I hope they will not have a problem following these videos, and they can, catch up with the classes. So please go through this video because these are very important concepts that you're learning. Okay. So if I think we are already 10 minutes extra time, so I think we can stop here. So we'll meet
Okay,
again
thank you,
tomorrow.
sir.
So yeah, everybody I hope has understood today.
Yes,
So
sir.
if you have not